So hey everyone, respected faculty members and all the tech experts. I made a super affordable mistake with my SCT 013 100 amperes to 50 milliamps current sensor. Actually, I had done the primary winding modification in such a manner that the primary uses 10 number of turns and the secondary has 2000 number of turns, but we can't change the secondary winding, but we can change the primary winding according to our requirements. So the problem with my sensor or circuit was that I had used 10 turns, so my device was getting saturated at 250 watt load. So I had to decrease the number of primary windings and again calibrate. You can see this box contains the circuitry. There is a burden resistor, these two voltage divider with filtering capacitor, and this is a 4x4 inch box, and all these component fits inside the box. And if we further want to increase component like this voltage sensor, we have to go for bigger box. So I don't recommend you to use 4x4 inch box, or I will recommend you to use 4x4 inch box when you are using ESP no 32 or Node MCU. I don't recommend this type of box with Arduino Uno, but I don't have other option available because Uno is the only small size board that works with 12 volt, as I am powering it up with my 12 volt battery banks. So during the daytime I had to fix the winding. Now currently doing the calibration of this ZMPT voltage sensor. So this is the V versus I graph, I think, input voltage graph. So I had to add a significant delay. Let it say 50. Now let's recheck the program and re-uploading it. The connection is quite simple. The first pin is VCC, second pin is analog output, third pin is ground. And be careful operating with this thing because here we have high voltage AC. So I won't recommend non-technicians to work with these things. So after increasing the delay to 50, the graph is little slower. So I had to, and we have lots of spikes here. So I had to further increase the delay. Say I will make it now 100 because of AC frequency is of 50 Hz. So 50 ups, 50 downs. Let it make it something more, the say 100. If 100 doesn't work, then by hit and trial I will make it 200, 4 times the 4 times the AC frequency supplied at India. Where is the serial monitor? Yes. So I am getting some graph like this. So now I had to adjust the potentiometer gain here. So I will hold with my hand because I don't have a clamp, so I have to pause the recording. So guys, right now my power is off. This is the wire that comes to my voltage sensor, and you can see it is still generating some random spikes or noise, but its peak value is much less, something max, what can I say, 0.44. This is the peak value. So now let's check when this thing is getting powered, what are the result. And with the help of multimeter I had checked, my supply voltage is 220 volt AC. Let me show, and never ever try to do this. Sorry, I have 2 leaks. So yes, the supply voltage is 220 volt VAC. Let's do some rough sketch.